All right. Hello, everyone. Thank you for joining us today for the EA's workshop on sustainability and resource efficiency in public and private Ethereum networks. The first part of today's call is being recorded and will be available to all attendees and the public on the EA YouTube channel soon after today's presentation. The Enterprise Ethereum Alliance enables organizations to adopt and use Ethereum technology in their daily business operations. The EA empowers the Ethereum ecosystem to develop new business opportunities, drive industry adoption, and learn and collaborate with one another. At this time, we are pleased to introduce our moderator, Ken Fromm.
Hello, welcome everybody. This is a workshop on sustainability and energy efficiency and resource consumption. And by that, it means that we want it to be a highly interactive session. After the interview, we'll have everybody turn their cameras on and wave and be a part of the group. However, since it's been recorded, we ask that if you're not Carl or York, we ask that you turn your video off. Also, we'll be using Kiko Chat as the navigation to the different breakout rooms. We're using Google Docs for the agenda and the summary report draft, and then we're using, of course, Zoom. So there's 3 different platforms here at play, so hopefully you'll be able to navigate, click the right buttons, and be able to follow along with the instructions. It's a relatively short program. We've got an interview, we've got the breakout sessions, and then we've got the reconvene in the main room to hear all the great ideas from the breakout sessions. So let's kick off with the interview, and it's Carl Beekhuizen and York Rhodes III, and I'll turn. Carl is an Ethereum researcher at the Ethereum Foundation, and we're specifically working on eea-eth and scaling for the last 3 years. And York Rhodes is the EEA board member and co-founder of blockchain at Microsoft, and a researcher in his own right on blockchain and energy consumption and conservation. So let me turn it over to you and take us away.
Topic. Clearly for enterprises like Microsoft who have committed to removing their entire carbon footprint from 1975 when they were founded, sustainability is a really important topic. And so any technology, the impact of the scope 1, 2, 3 and emissions of that, we report on it in a sustainability report to the public. We also have an internal climate tax for any businesses that need to actually mitigate to their footprint. And so we're very deliberate about this. Our Chief Environmental Officer, a long time, and so very excited to have an opportunity to speak with Carl this week and really dig into sort of how do we think about this from an Ethereum Foundation perspective, and the nuance between where we are today in terms of the proof of work production network and a migration to the proof of stake production network. So maybe we should start there. Clearly these are very different footprints. Carl, maybe you can give us a sense of how different they are.
The difference between proof of work as we currently have it on Ethereum and this transition to proof of stake, it's hard to describe the extent to which these are different. I mean, I can put numbers to it, but it's something like 3 orders of magnitude, 1,000 times less energy consumption, and this primarily comes down to the purpose of energy within the system. Why is energy consumption something that we care about or that we see within these blockchains? In the context of Ethereum proof of work and Bitcoin being the 2 largest, but all the other large proof of work chains, the reason we see so much energy being consumed is because it is necessary for security. The security is provided by having the honest participants use more energy than the people who are dishonest or trying to attack the chain. And because you don't know how strong the attacker may be, you have to assume that they're really bad, and you have to provide enough incentive to basically use lots of energy to secure the chain, such that it's not feasible to even imagine what an attacker would look like or have to do to attack these chains. So we see this incredible amount of energy usage on the scale of countries for the proof of work chains, which is horrendous. It does, in my opinion, is completely unacceptable for the gains we're providing as a technology in the long term. And so moving away from this is a dramatic improvement. And proof of stake brings about this, amongst a myriad of other security and protocol improvements, brings about this change by no longer securing the network under this expenditure of energy, and instead relying on similar assumptions, but with staked, some kind of staked asset. And in the case of Ethereum 2, or Ethereum proof of stake, as we're calling it now, and that is staked ETH. And instead of now having to have more energy being spent by an attacker, or the honest people have to spend more energy in a proof of work context, now we have to make sure that there's more honest money or ETH locked up. And because of this change, we can dramatically re-architect the system where the energy is now no longer just being spent for the sake of spending energy and trying to outdo whatever bad attacks you can see on the system, and now purely comes down to what are the energy costs of just making the chain progress. How do we sanity check everything that's happening on chain and move on from there? And because of these things, we're looking at something like 1,000-fold improvement in energy consumption.
And I think to look at it from a sort of a layman's comparison, proof of work is basically paying GPUs on a machine, right? And proof of stake is essentially effectively a VM that has to be live, right? And that's obviously, when you think about the how a machine reacts to that, whether it's a laptop or a VM in the cloud, you can hear a fan running when you're playing GPU intensive games, right, on a PC, versus something that's just effectively idle, right, and just has to have liveness as the key aspect of its connectivity to the world. It's pretty easy to see that the difference between these things is pretty dramatic, right, just from the footprint of the individual node's perspective. Let me ask, so there's, when you look at this area, it's pretty highly complex because of all the variables that come into play, and actually getting to calculations is hard because of all those variables, right, and assumptions that you have to make about it. But in a perfect world, as we go forward into proof of stake, do you think it's possible to actually bake some parameters into the protocol that would allow us to identify regional block mining type of hardware configuration used to do that? Give us a better sense of, you know, getting beyond the assumptions to get more specific about the data, you know, where the work is happening.
In a proof of work context or in a proof of stake context?
I was really talking about proof of stake specifically, right?
So the reason this question is complicated and that we see so many assumptions and calculations is that we intentionally design a system where we obfuscate who the people are. Part of the security that's provided is that you don't know who any of these participants are, the whole pseudo-anonymous idea. We continue on into this proof of stake scenario. And this exists at multiple levels. So we don't know who the people are behind the keys, but we also don't know your IP addresses, which supposedly link you to some country or area. We actively encourage people to try obfuscate that, use VPNs or Tor similar infrastructure to help improve your own privacy. Privacy is a fundamental thing we care about, and this ties a lot then into what makes this difficult to understand the energy consumption. But that's not to say we can't do anything. So while we may not be trying to target specific metrics, we can think, instead of about regions, we can consider the different participants and what their consumptions may be. So how would an exchange or similar institution, what does their energy consumption look like? How does the scale across a cloud instance running tens of thousands of validators versus what does it look like at home? So for home stakers, it becomes very hard because the hardware you're using, if you're using older hardware that you may have just lying around at home, it's great because you're not maybe buying new hardware. It's an old computer you had lying around is probably sufficient to run this. So that's fantastic. No more embodied carbon. You're not buying new devices. But on the flip side, it's going to be less efficient from an energy consumption standpoint. Mm-hmm. Fortunately, it's the whole proof of stake thing is pretty reasonably efficient. So I personally estimated something like, the worst case, about 10 watts per validator that you're running, including running a beacon node and all those good things. But beyond these kind of rough estimates, I think that's about as good as we're going to be able to get from the user side. We've launched some surveys to try and understand all of this, but you end up with limited subsets of the community. Mm-hmm. On the flip side, for institutions, then I think we can really dig into the numbers. And I think we should, as a community, be demanding this from these large institutions in the space. If you are going to be delegating your stake to someone, maybe a deciding factor for you is that they do this in a way that is more friendly towards the environment. So what devices are they running it on? Are they using cloud providers? How are these cloud providers, how are they trying to offset their carbon, if they are or not? These, I think, are very interesting questions that we could go a lot further in demanding it from these institutions, and B, making sure that this actually plays out. And I think by creating awareness that we can maybe get people to move towards this being one aspect of your decision-making process in choosing a provider.
Mm-hmm. Yeah, and I think, so if you go a little bit further, understand the sort of the value proposition of privacy and such, and that's how you get to your delineation of whether it's somebody who wants to be private versus large institution that by definition is not going to be private, right? But from a data perspective, it's actually a valuable set of essentially requested but optional data, right, that you could actually encode into the system that would actually provide probably, instead of having to do a survey after the fact, you could actually just get it from chain data. And I think that would be interesting across, the type of information you're referring to, like in these surveys, where you can, or in the data that's being mined on the proof of work chain, right, where you can figure out what the hardware profile is. You can figure out, in some cases where the IP address is, right, coming from, so you can actually estimate regional power consumptions, type of power in the region, and things like that. And I think particularly in the context of large enterprises that are consumers of this technology, like Microsoft and others, that have a very high bar for like justifying why we do certain things in a certain way, and the fact that we can collect data about other things, just for a sake of argument, like if you're running an Xbox, it has an IP address, right? So assuming that has not been obfuscated in some way, you can actually see that, like, my Xbox is running in Brooklyn, right, where I live, right? And so then I can make assumptions about the local energy. So I think this is it's an interesting thing maybe to think about it, just like particularly if it's a set of metadata that could be provided in a requested but optional way, probably would get a larger swath of participants as we look to sort of green the whole infrastructure going forward.
I definitely think something like that is possible. Again, it would, even if it is opt-in, I would encourage it to be in a privacy preserving way. So maybe something that says, I'm a part of this bucket of consumer. So I've happened to find myself in, I don't know, China or Europe or something like that, some large geographic region, which gives you some anonymity set just by the function of how large the area that you're saying you are is in, and possibly a similar thing for hardware, as in maybe there are 5 choices in terms of what you expect your hardware to be doing. I could see something like that being an option. I wouldn't feel comfortable driving this myself as a protocol researcher, because I feel like this is one of the areas where if there's demand from the community, I'd happily implement it. And I think there are ways in which it could be done in a reasonable way, but I wouldn't feel safe or I wouldn't feel like it's the correct approach to impose this on the community from the outset. And there's this like weird dichotomy of like things, and there are many instances of this that I personally would like to see happen, but we can't, or we choose not to enact as protocol researchers in order to achieve other alternate goals that we think are more important in the short term, potentially. Yeah.
And you know, I'm aligned with your privacy point, and segmenting users into buckets, right, is actually a good way of abstracting away from very specific user data. So I, you know, fully align with that. What do you think about what Celo has done, for example, on their chain, where they actually have a percentage of their rewards going into a climate fund?
I think that's very interesting. I think this, if you're bootstrapping a proof of work network at the moment, you should definitely consider doing something like that. As a proof of stake network that's already running, it's much harder to make these changes. So we've had very similar discussions around how do you support the people building the protocols. So the funding raised by the Ethereum Foundation way back when to sponsor Ethereum is much smaller than what we see from the protocols now, which are being built on top of Ethereum. So that's interesting to see that sort of these much smaller protocols built on top have much larger kitties to contribute to this. And so there have been proposals in the past to help finance the people actually building the chain and researching the chain underneath everything. Not that we finance constrained, but just for the sake of explanation. But to try build on top of this and to have maybe a development fund. And we've seen quite a lot of pushback from the community as to like, how do you actually manage that and ensure that? And it becomes a very political thing very quickly. And that would be my fear in this case. So while I like the idea and like abstracted from politics and implementation, absolutely is fantastic. But I think once you get into the nitty gritty, it gets way more complicated in terms of how you actually achieve it. So I think more interesting approaches would be if protocols themselves, say, pick your favorite exchange or something, say Uniswap, took a portion of the fees that they give back to the liquidity providers or whatever, and took a portion of those trade fees and used that to offset the carbon emitted by the transactions they're emitting. I think that would be an easier way of achieving it from like a community standpoint, and then users could decide whether they're going to go to an exchange which has these functions built in or not. I think choice is fundamentally one of the things we try to build into these protocols, and I'd be a little bit nervous, particularly retroactively, trying to couple some external climate fund into the low-level protocol.
So that seems like a pragmatic approach, and it sort of aligns with some of the work that we're doing in the Green Software Foundation, where we think about how do part of my development practice, how do I actually create efficient protocols and efficient applications, right? And look at what is the value stream of the development cycle of the entire thing I'm trying to create. And that's really part of the challenge of you know, the ESG space and the sustainability space, is really looking at the full life cycle of you know, what is, you know, what's happening, right? And when I look at the end application, for example, of an NFT, in order to get to the acquisition of an NFT, there's a trail of activity associated with acquiring the appropriate tokens, right, in order to purchase the NFT, and all the other parts of the activity actually come into play. And this is important when you look at you know, the scope 3 aspects of you know, the climate accords. So, you know, I think really digging down into specific ways that we can think about design value chains, application value chains, is not only going to be desired, but necessary over time.
I think an interesting extension to this is lots of the layer 2 scaling solutions that we're seeing coming out.
Agreed.
Those offer a nice option for having a more centralized provider, but still being able to have similar trust assumptions. And because we have now a more centralized provider, we could have demands for better reporting in terms of their climate or their carbon offsets. And then NFTs or artists can choose to a particular layer 2 to launch the NFT, particularly because you know that they're going to be carbon offsets or some other similar metric that you care about in this regard. And I think that might be, in the long term, a nice way of solving this, because from a protocol design perspective, that's the way we would like to see all the activity happen, is to move to these layer 2 solutions for these scaling things benefits, because it allows us to have centralization, which provides a myriad of benefits. Most of the efficiency gains that you ever get in a protocol translate into environmental gains. So when we design for faster, cheaper protocols, that also makes things better for the environment. And so all these things that we care about from just like purely designing a better protocol lead to improvements from an environmental standpoint.
Yeah, I think
that's exciting.
That's an excellent point, Carl. And we didn't really talk about impact per transaction, but the fact that you can do such more transactions per second, right, on a layer 2 environment means that will actually dramatically improve the impact per transaction on a network. So 100% agree with you, and thank you for closing out this some time to speak with you. And I think we're going to transition over here into either questions or the next session. So thank you so much, Carl. Look forward to talk to you soon as well.
Absolutely. Thanks for the discussion.
Yeah, thank you so much, guys.
Yeah.
At this time, I'm going to go ahead and stop the recording.